Okay, so once again, good morning, everyone. So this time our topic is all about measures of variability. No, so measuring a variability, we could able to determine the relative variability of two distribution, computation of range, interquartile range, variance in the populations, variance from sample, and compute that standard deviation from the variance. So when we say variability, actually, it refers to how spread out a group of score is. To see what we mean by spread out. Okay, and the terms variability again is spread and dispersion are synonyms and refer to how spread out a distribution is. Just as in the central tendency, where the measures of the center of the distribution of scores and the variability of distributions. There are four frequently used measures of variability, as I mentioned: range, interquartile range, variance, and the standard deviation. Okay, so to give us more details about the discussions of measures of variability, go ahead, presenter.
I am Diana Fem Altas, and I will be presenting to you the topic of descriptive statistics, measures of dispersion or variability. First, we will discuss the importance of measures of dispersion. The measures of central tendency are not adequate to describe data. Two data sets can have the same mean, but they can be entirely different. Thus, to describe data, one needs to know the extent of variability. This is given by the measures of dispersion. Variance is a key concept in statistics. The job of most statisticians is try to understand what causes variance and how it can be controlled. Likewise, it is a job of the statistician to explain the variance through quantitative analysis. Measures of dispersion as part of descriptive statistics. Dispersion refers to how variable or spread out data values are. For this reason, measures of dispersions are sometimes called measures of variability or measures of spread. Measures of dispersion are descriptive statistics that describe how similar a set of scores are to each other. Measures of variability provide information about the spread of scores and indicate how well a measure of central tendency represents the middle or average value in the dataset. The mean is the value usually used to indicate the center of a distribution. If we are dealing with quantitative variables, our description of the data will not be complete without a measure of the extent to which the observed values are spread out from the average. When using measures of dispersion, the following trends will be observed. First, the more similar the scores are to each other, the lower the measure of dispersion will be. Second, the less similar the scores are to each other, the higher the measure of dispersion will be. And lastly, in general, the more spread out the distribution is, the larger the measure of dispersion will be. Among the measures of variation that will be discussed in this report are the following. First is range. Second is quartile deviation or semi-interquartile range. Third, variance. And lastly, standard deviation and coefficient variation. Range is the difference between two extreme observations of the dataset. The advantages of range includes that the range is the easiest measure of variation, which is easy to understand and calculate. The disadvantages of range is based on two extreme observations, hence the values in between the range are not considered. Likewise, range cannot be considered a stable measure of variation because it is easily affected by fluctuations. It is usually dependent on the economies of scale. The formula of range is equal to the maximum value less the minimum value of the given dataset. The sample problem with given scores 98, 95, 93.3, 92, and 90 will compute the range to the maximum observation of 98 less the minimum observation of 90. Thus, range is equal to 8. In the sample problem 2 with intervals 85 to 89, 80 to 84, 75 to 79, 70 to 74, and 65 to 69, The range can be obtained by getting the difference between the upper limit of the highest class interval and the lower limit of the lowest class interval. Since 89 is the upper limit of the highest class interval and 65 is the lowest limit of the lowest class interval, therefore, the range is 89 less 65, which is 24. Quartile deviation is known as semi-interquartile range, which is the amount of dispersion present in the middle 50% of the values. The quartile deviation is the amount of spread between the first quartile and third quartile. It measures the dispersion in the middle 50% of the values in an array to avoid the influence of extreme values that often occur at either end of the distribution. The quartile deviation is an improvement of the range, but since not all values are included in the computation, it does not fully reflect the variability of a given series. Quartile deviation. The quartiles divide a dataset into quarters. The first quartile is the middle number between the smallest number and the median of the data. The second quartile is the median of the dataset. The third quartile is the middle number between the median and the largest number. Quartile deviation or semi-interquartile deviation is equal to 1/2 multiplied by the difference of quartile 3 and quartile 1. Given the following frequencies and classes, quartile 1 will be 71.375 and quartile 3 will be 79.98. Quartile deviation will be third quartile less first quartile all over 2, which is 79.98 less 71.375 all over 2. Quartile deviation will be 4.3025 or 4.30. The standard deviation is the standard or typical difference between each data point and the mean. When the values in a data set are grouped closer together, you have a smaller standard deviation. On the other hand, when the values are spread out more, the standard deviation is larger because the standard distance is greater. Conveniently, the standard deviation uses the original units of the data, which makes interpretation easier. Consequently, the standard deviation is the most widely used measure of variability. Mean square deviation or variance is the result of the sum of the square deviation divided by the number of items. The positive square root of the variance is called standard deviation. Variance is the average square difference of the values from the mean. Unlike the previous measures of variability, the variance includes all values in the calculation by comparing each value to the mean. To calculate this statistic, you calculate a set of square differences between the data points and the mean. Sum them and then divide by the number of observations. Hence, it's the average square difference. There are two formulas for the variance depending on whether you are calculating the variance for an entire population or using a sample to estimate the population variance. These formulas are population variance and sample variance. To illustrate sample variance, please see the image on the right side. The numbers in parentheses represent the corresponding table column number. The procedure involves taking each observation, subtracting the mean to calculate the difference, and squaring that difference. Then, sum the square differences at the bottom of the table. Finally, take the sum and divide by 16 because sample variance equation with 17 observations will be 17 less 1, which is 16. The variance for this dataset is 201. The standard deviation for the given dataset is the square root of 201, which is 14.177. What is the coefficient of variation? The coefficient of variation is a statistical measure of dispersion of data points in a data series around the mean. The coefficient of variation represents the ratio of the standard deviation to the mean. And it is a useful statistic for comparing the degree of variation from one data series to another, even if the means are drastically different from one another. Coefficient of variation is equal to the standard deviation over mean. The coefficient of variation shows the extent of variability of data in a sample in relation to the mean of the population. In finance, the coefficient of variation allows investors to determine how much volatility or risk is assumed in comparison to the amount of return expected from investments. Ideally, if the coefficient of variation formula should result in a lower ratio of the standard deviation to mean return, then the better the risk-return trade-off. Note that if the expected return in the denominator is negative or zero, the coefficient of variation could be misleading. This is the end of the presentation. Thank you and good day.